Hello everyone. Today we are going to discuss the shortest path in grid with obstacle elimination problem. I discussed the DFS plus DP approach of this problem in the previous video. Now let's discuss about the BFS one, and as I mentioned in the previous video, BFS will be using BFS in this problem will be way more easier, because when we were using DFS there were a lot of overlapping sub problems and we end up applying DP, and if you are someone who is not comfortable with DP, BFS is a solution that you should go with. Now let's quickly understand the question. I'll repeat on the question once again. So it is asking you that you have to start from 0, 0 and you have to reach to the very end of the box at the end of the day. So it is saying that from 0, 0 you have to reach the n, 1 n minus 1 comma n minus 1 box. That's all it is asking. And if we see, it is a very common question that you guys have must done using BFS approach, that you are given a box and you have to reach to the end of the box. You always do that, okay, I'll explore all 4 directions, and at the end of the day, the moment I'm able to hit this point, this is the steps that I took. So there are 2 different things in this question. One is it is asking that you have to find the minimum number of steps it will take from you to reach start from this to reach to this particular point. That is one point. Second thing is it have given you an additional k value. This k represent how many obstacles you can skip to reach from this to this. So if your k is 1, it is saying that out of these 4 obstacles that you can see, you can skip one of these, and then tell me what is the minimum step it will take for you to start from here and to reach till here. So that's it. It is asking. That's all it is asking. You have to use a BFS approach here. Why BFS? How BFS? We will explore all 4 directions. The moment we hit an obstacle, we will check, do we have the bandwidth left with our safe obstacles that we had, that okay, we are allowed to skip, let's suppose 3 obstacles, or let's suppose 2 obstacles. So the current obstacle that I have hit, I'll check how much k is left. If you have more than 0 k is left, that means you can still skip this particular box, and if you can skip this particular box, you will see, okay, that means I can come to this position, and from here I'll check that, okay, what all position I can check at the end of the day to reach this particular box. That's all is there in this question. I'll quickly go through the question the approach ones. We are using a directional array. This basically represent all the 4 directions that we can explore. This is a very interesting condition, which if you quickly go through it, it's not very complicated. So what this is saying, you have to start from here and you have to reach till here, right? And what is the minimum step? Let's suppose there was no obstacle. What is the minimum step it will take for you to start from here and to reach till here? It is row plus column. Do you agree? No matter what other combination you take, row plus column will be the minimum steps you can take to reach to basically cover this particular box, correct? So that's what we are saying, that if we are allowed to skip k boxes, and those k boxes are actually more than equals to my row plus column, that means in the worst case I can skip all of them. In the worst case I can skip all of them and I'll directly return row plus column. What I'm saying, let's suppose this box was all over the place, and I am given that in the you can skip k boxes. K boxes is the number of boxes that you can skip. So I'll skip the minimum number of boxes that can help me to reach or to cover this particular space in the minimum number of steps, right? So the minimum number of steps is row plus column. So that's what I'm checking, that if my k obstacle is more than equals to row plus column, in that case I will return row plus column, saying that I have already discovered the minimum number of path or number of steps I will take. So this is the path I'll take. So this is just an if condition, base condition we can say. Now let's start with our BFS approach. We will take a queue. In the queue we are saving 4 values. It is an integer array that we are saving inside our queue, and it will have 4 values. Your row or your ith index, your jth index, your steps that you have taken till now, and the number of obstacles that is left with you. That's it. That's all you are saving in your queue. You are having a visited Boolean array as well. This is a 3D visited array. Why we are using a 3D array, I'll tell you. You just can't take row and column and be happy. No, your value or your visitation at the row and column will depend on the k as well. Why we are saying this? Let's suppose you are on this box. Your value could differ based on your k. If your k is 0, then the minimum number of steps you will take will depend that okay, you have to take this step. But if your k is 1, you can skip this and you can directly take this path. But if your k is 2, you can directly skip all of them and can reach here. So that's where we are making sure that even though a row and column, a particular piece of row and column is visited, we are making sure that is this visited with this particular combination of k or not. So that's why we are using a visited array, that okay, this is the combination that we have already visited. That's it. Now what we will do, we will start popping out from the queue. We will pop all the 4 values that we just saved. We will check that if any of them is able to hit my my required target, then I'll just return the steps from there. Else I'll go in all 4 direction. We'll check the if condition that I'm not out of bound and I'm 0. What 0 and 1 represent? 0 represent the empty box which we can explore, and 1 represent the obstacle. And as mentioned, that you can only surpass obstacle if and only if you have some k left. That's what we are checking, that if it is equal to 1, make sure that you have some obstacles to skip. You have here k which is more than equals to 1. So this was just a small if condition. And what we are doing, we are this might look a bit complicated, but whatever obstacles that we are left with, that is left with us, we are just subtracting 1 from it. This will tell me how many obstacles we have right now with us. So let's suppose your obstacle were 3, and it is your grid of I and j can either be 1 or can either be 0. So if it is 0, we do not have to worry, your obstacle will remain 3. But if it is equal to 1, that means you are on one of these red boxes, and that means you have used one of the obstacles or one of the power that you had. That means now it is subtracted by 1. So it is not complicated. This is just equal to, if I have to shorten it out, or maybe I have to clarify it, so it is just equal to this and this. That's it. And this is equal to this. So it's exactly the same thing that you are doing, that if it is equal to 1, you will reduce your obstacle to 1 because you have already occupied or used one of the k with you. Else you will now check if the particular combination of I, j and this k, if it is already visited. If it is already visited, that means I'll not visit it again. It is there in my queue already, but if it is not, then I'll add it to my queue. I'll make it true. That's it. And I'll, at the end of the day, the moment I'm able to reach to the end point, that's it. That is my end point, and I'll return steps, and that's all. That is all the question is about. Now you might be thinking that why DFS was causing issue. Why with DFS approach I had to use a DP? Let me tell you. So with BFS, what you're doing is starting from this. You are exploring these 2 boxes, then you are exploring these 3 boxes, then you are exploring these 3 boxes, then these, and you are able to reach to the end point. And the moment you were able to reach the end point, that means it was the earliest, or it was the first hit that you got. Now whenever you will be reaching to this point, you will always be increasing step by 1. So if we come to the minimum 1, the first time that we were able to reach here was the minimum 1. That's where BFS have helped us. But with DFS, the problem is we are not calculating, or we are not checking one box at a time. We are exploring one path completely and then coming back to explore the next path, and then coming back to explore the next path. In that case, you will be reaching this again and again and again and again, and in the end you will be checking which one is the minimum one. Give me the minimum one. In that case, there is a lot of possibility of overlapping sub problems. You will be reaching a particular combination of box with a particular I, j and k, and that's where you have to use DP. But with BFS, or with this question, or with this approach that we just discussed, it is very easy. We are exploring one box at a time, and the moment we are able to reach till the end was the first or the minimum steps that we can get out of it. I'll quickly discuss the time and the space complexity. So if we talk about the time complexity, each box if the total number of boxes that we have are n, then each box, in the worst case, we can traverse over each box with k combination. So your time complexity will be of n cross k. If we talk about your space complexity, then the same thing is happening. We are using a visited array with n cross k. And if we talk about the Q space as well, that will be n cross k as well. So in the worst case, your space complexity will be n cross k, which is better than the DFS one, because over there we were also using space in the recursive stack as well. So considering all these points, I'll prefer to use a BFS problem in these conditions. So whenever a grid problem comes to you, think that how a BFS problem can help you before thinking about the DFS one. So that's all. Hope this helped you. Let me know in the comment section if you need the solution as well. But that's all. Thank you.